Welcome to another episode of AI with Sally, an EE Times podcast that brings you inside my conversations with luminaries of the AI chip industry. Last time I sat down with Sameer Wasson, CEO of IP company MIPS. He told me the company had absolutely no plans to make chips. Fast forward a year and MIPS has launched a silicon platform, Atlas. In this conversation, I explore Atlas with Sameer and we talk about how MIPS is staying true to its IP-first DNA while expanding into a new territory. We also dig into how MIPS is enabling deterministic, low-latency AI inference at the edge, why the shift to RISC-V is unlocking new levels of flexibility, and how MIPS' approach is evolving to help OEMs rapidly deploy custom silicon without the traditional overhead. Sameer unpacks what this means for edge compute architectures and why control over the full silicon stack is becoming mission critical. Here's my conversation with Sameer. Okay, Sameer, welcome to the show.
Thank you for having me.
So last time I was here, which was a year ago, you said absolutely no way, no plans to become a silicon company. And then I read some of the coverage about your Atlas platform in the press, and it seemed like maybe you are going to make some chips or head a bit in that direction. Tell us a bit more about Atlas and what that is and what that means for your business model.
Yeah, I learned my lesson, never to say never. But no, so look, fundamentally at the core of it, 12 months back, we were starting our journey and we were very focused on making sure we are building foundational IP targeted at certain markets. That has come along well, and we are super focused on motor control, motor physical AI, and making sure that we are coming up with solutions which are differentiated and solve that problem well. Okay. What has happened on the market and the business model side has honestly been an interesting evolution for us to watch and observe and then start participating in. Over the past 12 months, as we started engaging with customers on our technology, we started feeling a vacuum in terms of how these customers could access the technology. And this discussion on existing players changing their business model or evolving their business model honestly gave us an opportunity to engage in a discussion which was broader than just delivering IP. And I think that is where our business is headed, where IP is very fundamental. I see that business growing well for us, both sort of organically, but also to a large extent inorganically, thanks to what our large competitors are doing. Because that space where we're focusing doesn't seem to be a big focus area for them. So I think we will go leverage that and build solutions. But in addition to that, what has come around is, like I said, coming back to the vacuum which we felt the customers had on how do they get access to this technology. And the classical channels of waiting for a large product company to adopt the technology, bring it to market, sometimes wasn't something these OEMs were looking for. Because very much similar to what we've seen on the data center side, once you start seeing the opportunity of what AI and physical AI can do to your business, for your business as well, and to your business, you automatically get to a point of saying, how do I get this technology faster? And we, as a company, have decided to meet the customers where the demand is. And I think our platform, which we announced recently on the Atlas side, the portfolio, the M8500, and the Raven Drive 22 nanometer platform, that is a very key investment where that is a starting point for customers to then consider customizing it for their needs. And so no, I think we will do more than IP. What I'll now tell you is, without using the word never, we do not have any intentions as of now to become a product company. We don't want to be in any way competing with our customers on the IP side. I think we will enable our OEM customers to do more with our IP and potentially deliver custom solutions to that. But we do not intend to go out and build a portfolio of standard product devices. I think we want to stay in the design enablement realm and give our OEM customers an access to the technology they want in the form they want.
So it's more like a custom ASIC business combined with more like a compute subsystem.
Yeah, so compute subsystem, so subsystems is a very, very fundamental part of our IP business also, right? The days of us showing up with a shiny core, I mean, they're good, but very few customers are looking for that, right? These chips are getting so complicated, they want to talk subsystems. So that is absolutely ongoing. On the chiplet side, there will be a time when we start hardening those subsystems. I think that will happen not organically. There is time before that becomes a vibrant IP market, right? I think the IP space will evolve over the next few years, where chiplets is the new IP to large extent. I'm not the only one going to do that. We will follow the trend on that and steadily progress on that. It's a good thing for our business. I mean, there is growth there, but I think there's evolution to get to an IP marketplace where chiplets are standardized and all of that. What we're doing is we see a large number of OEMs who want custom solutions, but are not able to get through the barriers of adoption of a custom solution. So what we're trying to go focus on with our IP portfolio, the Atlas portfolio, but also our tooling, Atlas Explorer, which is a very fundamental part of our strategy, is how do we go reduce the barrier for those customers to adopt a custom solution? And it needs to make business sense, because doing a custom solution for a 100K unit opportunity is not going to work. But most of the customers we're engaging with tend to be the top end of the market share. And they have enough volume that if they are able to see a path to a sensible custom solution, they don't want to be left behind on the physical AI side, and they want access to technology. So our job is to try and service the market. The market is IDMs, IP, subsystems. The market is OEMs who build their custom solutions today. We service hyperscalers today who are building their own custom solutions. We service auto OEMs today who build their own custom solutions. And then the third vector, which is starting to grow, is customers who are not doing custom in the markets we are in, but have the curiosity because AI is starting to permeate down there, and they want to pull us and see whether we can help them bridge that.
So it's basically going to allow you to move up the value chain a little bit as well, right? That's part of it.
Absolutely, right. We have to, right? It's the outcome is that we move out of the value chain. The desire to do it, as much as I think it's good for us to move up, is more about trying to go expand our customer base. The challenge in the IP business is the customer base does not, like I can't theoretically wake up and say, I have thousands of customers, right? I have a captive set of customers who have their own timelines and evolutions they're going to go through on moving platforms and spending R&D. The speed at which that base moves and the OEMs move may be different. And like we were talking earlier, right? Anything around AI has become so critical for people's growth in the future that the word control starts becoming more fundamental, whether you're a country or a large company. You want to control your destiny on AI. And you control your destiny by doing two things. First is you build solutions which are custom to your workloads. And second is you don't wait for someone to come and deliver to you that solution. You go find it. And if you put these two situations together, I think MIPS can serve both of these needs.
So people who are custom curious or OEMs that want custom, a big part of it is a big part of it is about controlling their own destiny and just having control of that supply chain and of that tenor. Okay, I see. Yeah, that makes sense.
Because a generic microcontroller doesn't cut it in some of these AI-driven physical AI applications. And how one robot company envisions control versus another robot company envisions it. I mean, we tried it for 6-9 months as we went out. Answers were different. So they're not like poles apart, but everyone wants a little bit of saying, hey, can you do this differently? Can you do that differently? Here's my workload, which is slightly different. So I think that's the need.
I mean, I'm used to hearing about this in the automotive space, where all those automotive OEMs want to make their own chips, even big chips. because they all have completely different requirements and they are indecisive also at the state. Like, it's too difficult for chip companies to make a product to cater for them. But this is the first time I'm hearing this about robotics,
Think about it,
actually.
right? So a modern car has the number of ECUs in a car are coming down. But let's throw out a number. If they're not 300 ECUs anymore, let's throw, say, 100 ECUs in a car. So far, an auto OEM's desire is to build custom chips for one of those ECUs. The other 99, they still rely on catalog. I think, again, it's not going to go from 1 to 100, but I think we're going from 1 to 5.
Okay. Still 5x, right?
5x.
Yeah. Okay.
So there is still a very large catalog play in automotive. It's not like that's going to disappear. Sure. But the next 4 ECUs is what I think we can help with, where our focus lines up very nicely with what those ECUs are doing in a software-defined vehicle architecture, what they're trying to go drive in terms of how do I make sure the car has a personality, which is unique to me. How do I make sure that I line up with the latest stacks out there? How do I make sure that it works with my ADAS stack well so that the user experience is this? I think that's where it's driving the need for that custom. And that's what we want to feed. So it's not about feeding 100 ECUs. It's about saying, right now you're building, or you're thinking you're building custom for 1. How about 4 more?
So for the Atlas IP, for MIPS, last time I was here, we talked about hardware multi-threading, we talked about tightly coupled memory, we talked about enabling heterogeneous compute, coherent system interconnect, data delivery, efficient data delivery. All of these MIPSy things are going to be in your new compute subsystem, right? You're going to maintain everything.
Oh, absolutely. I mean, it's been I've been on board for about 18 months, almost 2 years now. The journey has come along because I think we've stayed true to what MIPSiness is. And MIPSiness still means you're going to have data-oriented processing tasks, which we can do better than most people out there when it comes to latency, power consumption, focus on our edge. That focus is very, very fundamental. Now, we build IP which goes into data centers as well, nothing against it, but even in data centers where we have a footprint and we are adding more to that, are places which are very data-oriented. Like you will see us in DPUs, you will see us in feeding AI accelerators, you will see us there. You will not see us as the main CPU today anywhere. I think we are more of the data movement engine, and I think we like that position. Now, when it comes to the embedded side, or when it comes to the edge, most of the issue is latency and data movement. So that TAM suddenly explodes for us even more because there are a few edge applications where you need to run a screen. I think there are architectures out there who run screens better than most ever will. So we don't want to go compete with that. We want to go focus on markets which are very low latency, very real-time processing, and be that engine. And if you think about edge AI or if you think about inference at the edge, it is a data movement problem.
I guess with the subset, if it's a compute subsystem that you're supplying, it gives you control or gives MIPS control over that data movement around the subsystem as well, right?
It's workload also, right? It's many of these things, the data movement often crosses boundaries of analog and digital. So if you think about a MIPS subsystem now in real-time application, it's not only a digital compute engine, right? We are also making sure that the data coming from our analog sensors has direct access into the compute. That compute has direct access into the AI compute, and then we can get that out processed as quickly. So our skill set is absolutely expanding beyond the realms of only digital, because if we can't move data from analog bits in very quickly, we're going to lose there. So I think we're working those interfaces as well. And I think there's a lot of interesting innovation to be done in how we move analog bits into digital processing and get them out at a very low latency, which are very unique to the edge, right? Nobody cares about that as much on the data center side. But once you're talking real stuff, it's all analog around you.
All right, what can you tell us about the AI engine in the new Atlas platform?
Look, at its core, it is an IP-first approach, which means it is foundational technology for customers to come and use that in a pretty modular format to scale to their workload. So there's no restriction on how much you can scale on that. It is very, very RISC-V. What I mean by that is we are modulating its development to make sure that we stay in sync with RISC-V, because I think the total cost of ownership on anything proprietary on an AI engine is going to be probably one of the largest limiters of its adoption. Like, we have seen many solutions in the market today, and Sally, you speak to many of those companies, and their KPIs are very impressive. Like, most companies who have come up with solutions have pretty kick-ass KPIs, except for their business KPIs, unfortunately.
Yeah, no, that's fair.
And one fundamental reason for that is the total cost of ownership on a custom stack runs into millions of dollars from a software development perspective. Yeah. And the strategy we are taking at MIPS is we are building it, but we will build it in conjunction with the community, so that when we are ready and the community is ready to go, say this is a standard piece of IP, the adoption is much faster. Yeah. So that's just in terms of the philosophy of, like, when we spoke last year, I said we're not doing anything yet, is because I didn't see that standard. The standards come along, right? The vector standard is already there. MATML is starting to shape up. So I think we are now kind of moving forward and saying, all right, we know what we're trying to say. We'll be in the same range. So that's number one. Second one is anything beyond IP, like going back to our custom business. We will focus building those subsystems which are AI in the loop on edge AI applications. So rather than building standalone accelerators, I think we are still looking at embedding this capability in day-to-day embedded applications, which are around control and processing. So that modularity is very fundamental to us.
One of these MIPSy things that we haven't mentioned yet is the ability to add custom instructions, which I know is something you're very strong on. But how do you square that with being a part of software compatibility and based on the stuff we were just talking about, right?
Yeah, and again, that's also, we're becoming wiser in how we look at the world, right? When you start off, you're like, my instruction is differentiated, I'm not going to share it with anyone.
Okay, yeah.
Then you wise up and you say, you know what, that seems right, but long term, it goes against what's going to make us successful long term. Yeah. And like I said slightly earlier, that the biggest risk to RISC-V is people who are doing RISC-V. Yeah. Right? It's not anyone outside of that. And if we can make sure that RISC-V stays standard and remains one, I think the adoption on RISC-V is going to be faster, better, bigger. Yeah. So we are very much part of that. We will make sure that we do not differentiate on instructions. Yeah. If we do an instruction, we are going to share that openly, upstream it, quote unquote, and share it with the community. So we are not leveraging custom instructions as a way of saying, look, our solution's better. I think we have architectural and implementation aspects which are going to be better, ecosystem, this, that, whatever. But we've got to make sure that we are staying standard. Yeah. We're also actively in discussions with other entities who've come across who want to have like automotive profiles like Quantaris and some others. Very curious on how they want to interact with RISC-V. It's still an evolving space. Yeah. But for us, standardization is pretty fundamental to where we're going.
But you have to move at the speed of the community, the RISC-V, the same speed as the RISC-V community.
Yeah, and look, we are very much part of the community. So us playing armchair quarterback on that doesn't work. Yeah. So what we're doing is we're putting our best engineers in forums which we think are the most critical ones. Mm-hmm. Everyone wants their people in like the fancy MATML discussion and this. Where we lead the discussion is debug and trace, honestly, because the community means it's a large group of engineers. Yeah. And the first thing an engineer looks at is debug and trace across it the same. Okay. Right? It's simple stuff like that. Okay. And can we get that right first? Yeah. So we are participating. We are going to continue expanding our participation in RISC-V to these committees, subcommittees. And we need to move. We don't need to move lightning fast because market is evolving. Yeah. But I think we need to just keep keep steadily progressing.
So, long-time readers of EE Times will know that MIPS was acquired by Wave in 2018, which was an early AI chip startup. And to cut a very long story short, Wave eventually ran out of funding, but MIPS survived. I understand you still own that Wave IP, so I wanted to ask whether there's any Wave DNA in the AI engine that you're building, but it's RISC-V, right? It's completely new, right?
Yeah, I think the Wave IP, when designed, was targeted at a very specific workload in the data center.
Okay.
And like I said, the MIPS play on the AI accelerator is not targeted at that workload.
Absolutely.
It is more targeted at the embedded workload. So there is no overlap on that, basically. Now, there are other uses of the legacy MIPS has of RTL, whether wave or non-wave, which as we go and try and bring the barrier to adoption on custom lower, we intend to leverage, especially on the tooling side, to make our tools more design aware, so that customers can engage on that more effectively. So there is a lot of benefit we get by having 40 years of legacy of RTL in a world where training on RTL can help us accelerate certain things which we're doing on the tools. And I think that we will do that.
So it's like you use all of the 40 years of RTL that you've got to make your design tools better by using AI, right? You're literally training an AI to do this.
Exactly.
That's so cool.
And Atlas Explorer, like the thing in our portfolio which we probably don't talk enough about it yet, and we will over time as we get further along, is Atlas Explorer.
Yeah.
I see that as the portal of customer engagement and delivery.
Yes.
And it just runs with the strategy of lowering the barrier of adoption for custom designs. Yeah. So if we can maintain our MIPSiness and lower the barrier of custom adoption, I think 12 months from now, we'll have some more good news to share.
Great place to finish. Thank you very much.
Thank you, Sally. Always a pleasure. Thank you.
Thank you so much, Sameer. And if you'd like to learn more about MIPS, please visit this podcast page on eetimes.com, where we have some interesting links for you. That brings us to the end of the episode. Please tune in again next time for more conversations around AI silicon and systems. If you're listening to this on the podcast page at eetimes.com, links to articles on topics we've discussed are shown on your left. AI with Sally is brought to you by Aspen Core Media. The host is Sally Ward-Foxton and the producer is James Eade. Thank you for listening.